Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's been really interesting, this workshop, I think, in terms of a big focus around data, and so we had a great session this morning looking at sort of education around data science. This afternoon we have a couple of more talks around education for data science, but we're kicking off with a talk by Liz Lyon, who's from the University of Bath, with the question, what is a data scientist? So over to Liz.
Okay, thank you. And I might add, Kenji's going to step in and we're going to do a kind of double act. So I apologise for not being here this morning. My plane was delayed. But hopefully I'm going to step back and challenge a few of the concepts around data science, recognising that you're all from different platforms, different backgrounds. So what do each of us mean by data science? So that's what I'm going to cover. We're going to unpack what a data scientist actually does, and I'm going to posit the idea of different flavours of data science, and then think about how a tool that we've been working to develop, a model, can inform thinking about the data science habitat. And I'll try not to mix my metaphors too much here, so bear with me about ice cream and ecology, okay? All right, so the first question is, what is data science? And I'm going to ask Kenji to chip in at this point and present one view.
So data science is interesting. It's a loaded term. This is a view from industry, which is what is data science. So search engines are data science. You could argue that business intelligence is data science. Okay, what are you trying to do if you were a business? If, for instance, you were a large company selling books, then you would look at all of the clickstream data, all of the things people are ordering, and you'd run lots of machine learning and statistics in order to create dashboards, create offers, etc. So that is a commercial application of data science. One of the things we've done in Microsoft Research, Forza Motorsport, is a racing game, and in the top right you can see a graph of the Bayesian analysis machine learning that's used in that game in order to match players with different skill levels with a technology called TrueSkill, which is also used in Xbox for movie recommendations. So again, an application of data science where there we're looking at all of the Xbox player data of every game that players play across the whole Xbox Live network, using machine learning to analyze that in order to match players. So this is a sort of industry view of what data science is and is able to deliver. So perhaps, perhaps, yeah. I mean, it's what does data science deliver at the end? Or what are you trying to get? Yeah.
It's not so obvious to me that business schools do teach that. And if they don't, who does?
Okay, that's a really good point. So let's park that one, and we can come back to that.
That's a good one. Yeah.
That's a good point.
The title of your talk, Jeffrey. I only ask questions when I think I know the answer.
Well, you can answer it in your talk for us then.
Okay, so I mean, business intelligence as a concept, as a phrase, has been around for quite a long time. There's quite a nice two-part piece sort of unpacking the differences between business intelligence and data science by Steve Miller, which was published this year. And I mean, you can kind of think about data science as business intelligence on steroids, or maybe working at web scale. That's another way of thinking about it. But there's clearly some similarities, but I think, you know, maybe there's some differences, and maybe one is a transition from the other. Again, something to discuss. So if we unpack this a little bit more, this is a Microsoft eScience workshop. So if we think about data science from the science perspective, we can think about it, science, again, working at web scale. So this is, the scale is, I think, very important. But we need to think about data in a completely different way. We need to think about data as a utility, just like the water that comes out of the tap. We need to think about data as an infrastructure, as a substrate. I'm going back to my ecological terms there. So data as a research substrate, as a platform upon which other things develop. And we can think about different types of research output, all focused around data. So none of this is particularly new, but I think it helps to understand where we're going with the next question, which will be about what is a data scientist. Now, recently I was privileged to hear Jim Hendler presenting his ideas about broad data. So this is moving from big to broad and recognizing that when you're working at web scale, the data is distributed. It's not all in the enterprise. And that, I think, is quite a key point. So I expect this slide was up this morning, or at least this reference to this McKinsey report talking about big data. The main point I want to pick out from here is the prediction of the shortage of data scientists. So a big shortage of data scientists by 2019.
Where? In the whole world or just the US?
Yeah, I mean, McKinsey was a US-based report, but...
90,000 deep data scientists. Is that 1.5 million broadly construed data scientists?
Okay, so lots anyway, lots. So there have been some various headlines as well. I've just plucked a few from different magazines. Sort of attention-grabbing headlines about, what is a data scientist, and again, indicating the shortage of data scientists. So let's unpack a little bit about what does a data scientist do. And this is where I'd like to start suggesting the idea of flavours of data science. So one flavour that I think we're probably all familiar with, it's come from the business world largely, is the analytics, the analyst, the guy who, or the lady who turns data into product with some nice concepts of data jujitsu. And this is quite often for business advantage. So using particular tools and tackling problems from an analytic lens, a data analysis lens, often involving a lot of mashing up of data. So, okay, so that's one perspective. Here's another perspective. So how many people read the data blog in The Guardian? Okay, so sorry, that's a bit of a UK-biased question, but I'm sure I know that there are other versions of it. But if we think about this data journalist idea, they're a data scientist. They create stories from data. So they have those skills of mashing up, of analysing data, but they're applying those skills in a rather different setting. And it often involves complex visualizations to help to get that story across. So there's a nice quote, data journalism is the new punk, if anyone's tweeting. That came from Data Blog. Okay, another perspective. So I work in a university. Those of you that watch the UK Research Councils will know that the Engineering and Physical Science Research Council required all institutions that receive funding from them to have a roadmap for the institution. And so this involves things like data management plans, having data repositories, and preserving data for perhaps up to 10 years. So that's another view of what a data scientist does, and it applies both to the advocacy that's provided to the scientists, but also the scientists themselves in how they practice their science. So I'd like to suggest that there's a lot of actions that a data scientist takes part in, and by so doing, I'd like to think that they get credit for their data. That's another thing to park for discussion, perhaps. Okay, the final view, if you like, of a data scientist is thinking about perhaps more the long-term sustainability of the data archives, thinking about the preservation, the curation activities over the longer term, perhaps thinking about adding value to the data through cleaning it, cleansing it, through looking at missing data, looking at redacted data, data forensics, data archaeology. Now, I don't have time to go into those areas in depth, but you see where I'm going with this. It's a different type of data scientist. And essentially, they are acting as a data steward. So just to recap here, there's an awful lot of different data roles, different data skills that are really sorely needed, right from the sort of institutional leadership at quite a high level, perhaps at Pro-Vice-Chancellor level, VP level. There's skills that are needed in developing roadmaps, strategies for an institution or an institute, right down to, how do I license this data set that I've just created and I want to share? So I'd like to suggest we can start to think about a family of data science roles, data scientist roles. And we've suggested a few here. And I think Kenji's going to kick off with a few words about the data engineer. Okay, we'll save that for a slide that comes next. But we're thinking about a data engineer, a data analyst. We can say a bit more about that. Just out of interest, how many people in the room think of themselves as a data analyst? Don't be shy. Okay, so we've got a few. Does anyone think of themselves as a data engineer? Okay, interesting. Data librarian. Yeah, I probably could put my hand up there. Data steward. Any data center people? Maybe, yeah, maybe. Any data journalists? Okay, yeah, great. So, so this is, and this is Jer Thorpe at the bottom, who works for the New York Times, and he calls himself a data artist. So just to add that one into the melting pot. So over to Kenji to say a few words. We've just got a couple of examples that we each relate to, which we're just going to talk about in a bit more detail. So over to Kenji.
So yeah, I think data scientist is all of those things. And therefore, when we think about a data scientist, you think, well, is there one person that can do all of that and is a jack of all trades? And clearly there are people who do that. But in organizations, in research institutes, companies, etc., you may have a separation of roles where you have specialists who have a particular skill set where they can apply their skills in order to deliver the most effective solution. And so the data engineer here is the sort of person who writes software. This could be also the person who understands machine learning and can write you a machine learning Bayesian algorithm, okay? Which the person who writes a story and works for The Guardian might not necessarily know, how to write a Bayesian inference algorithm. So the data engineer is somebody who can basically look at the platform and all the tools available and customize the methods and tools for the end user, for the data analyst, for the data journalist. Could be the person who writes a workflow tool that allows you to do the management of the workflow through to preservation and curation. So the person who writes software and what we call code focused, and they could use a variety of tools like R and SAS. They might be the database expert, the Hadoop expert. One of the things that we've been working on is this F#, which is a computer language which the most recent release, which you can play with here, is designed around data science and allows you to program at web scale. So you can preview tryf.org, which we launched today, so it's a little plug for our launch. But it's the first computer language which specifically has features where you can program across the web of data. So it's an example where it's a tool designed for this data engineer person. And so I think when we think about data scientists, we do need to think about this family, okay? And clearly, people can wear different hats. I would say that I wear the hat of a data engineer and an analyst. Sometimes I tell stories. So you can wear multiple hats. But it's interesting to think of, particularly with education, different people in that family have different skill sets.
Okay, so Here's another one. So I lead a project back at Bath called Research 360. So it's a JISC-funded project, and the 360 is this institutional research life cycle here in this diagram. So the 360-degree idea. And we're looking at data management across the University of Bath. And one of the posts that I recruited to help me to deliver this project was an institutional data scientist. So some of you may have met Kathy Pink. And her role is largely to do a lot of coordination and collaboration, because if you think about your university, the numbers of different individuals who have a stake in looking after the institutional research data, there's quite a lot. So you've got your liaison librarians, subject librarians, you may have a repository manager, you've got IT services, you may have a research support office who look after the sort of project details, the research project details. You might have doctoral training centres who are training the new postgrads, postdocs, and the researchers themselves. And bringing all those people together and having a coordinated activity right across the university to manage all the data assets, all the research data assets, is quite a challenge. So for me, an institutional data scientist is an invaluable post that is helping me to provide advocacy and support to the Pro-Vice-Chancellor of Research at Bath so that Bath manages its data effectively. And that helps us to implement the roadmap that we've written to support the EPSRC requirement, because, as I said, that particular funding council is requiring all universities in the UK who receive funding from them to have an institutional data roadmap in place by last May. So quite a challenge. So that sort of segs me into thinking about what I'm calling the data science habitat. And that habitat will look different depending on who you are. So if you're wearing a PI hat, you'll have one particular perspective. If you're the institutional Pro-Vice-Chancellor, you'll have a different perspective for research. And if you're a funder, a research funder, you'll have a different perspective again. And all of that data science and data science challenge is relevant and important to you, because you need to develop capability and capacity in the research population to make the science happen. So we've working with Microsoft Research, we've developed a community capability model which is designed to be used by different stakeholders, if you like, in data science, and to help them to understand what they need to do to make that data science happen. So if you like, it's the diagnostic element in that arrow. So this is a quick visualization of the tool, of the model, sorry, and we've identified 3 main areas: human, environmental and technical, and within those areas 8 different dimensions, which we've unpacked in a white paper, which I'll give you the URL for to download it. And what we've done is we've identified the different ends of continua, if I can put it like that, different continua. We're seeing each of these capabilities, these dimensions, as a continuum, and data science at web scale is at one end, if you like, of that continuum. And the idea is that the tool can be used by different stakeholders in data science to help them to plan, to help them to invest effectively if you're a research funder, and to help you perhaps as an institutional leader to develop capacity in a particular department or a particular project group. And I think we're understanding that this has been applied in certain areas. And perhaps, Kenji, are you able to say something about EarthCube?
I think Ilya was saying that you were using this from when we presented this last year, right? And it was helping you.
Yeah, that's right. One of the issues we looked at is
Wonderful, wonderful. Thank you for that. So, an acknowledgement to the team that's developed the model and the white paper. There's a URL. The slides will be up on my website later on. And a shameless plug from me for the next DCC conference, the Digital Curation Conference, which is in Amsterdam in January and has a particular theme around data science. So if you'd like to come and join us in Amsterdam in January, we'd be delighted to have you. So I'll stop at that point and look at my watch. I think we do have time for questions and comment, really, whether this idea of a family of data scientist roles is something that you can buy into.
What are the implications? I mean, you can still have I mean, almost any area has sub-areas, and so you could train people in those sub-areas, you could train people a little in all areas, you can have all of the above. So
I think it has implications for curricula.
Yeah, but I agree.
As you're suggesting, and perhaps curricula across different departments or schools. So you mentioned business schools, and we were talking about iSchools earlier. So there's at least two areas, and then there's the researchers in their faculty themselves. Carol?
No, I'll make you run. Go on, do it again. I actually find this quite useful from the point of view of selling to my university. So I have IT services on one hand who believe that they're creating tools. I have the library on the other hand who believe they're doing stewardship. I have people who are actually doing both in the faculties who actually don't take any notice of the library or the IT services. So actually being able to give them a role and being able to clarify that in the faculty or the university structure is helpful. I mean, of course, in some sense, it's nonsense because people will all have aspects of this when they're actually undertaking it. But politically, it's helpful to be able to highlight territorial areas. And for that, it's extremely helpful.
Okay. I think we've probably got time for one more question, if anybody has any. No? Okay. Well, thanks very much, Liz. Oh, hang on.
I think it'd be interesting to be training staff along these lines to actually build the courses and the structures within universities. I work in a major research lab in Australia, and we'd be an employer of people who, if universities were producing them, I'm sure we'd be happy to employ them.
Okay, that's really helpful. Well, I'll certainly take this back to the DCC and think about how we can move it forward in the UK context. And happy to work with anyone in other countries collaboratively. So thank you. If there are no more questions, thank you very much.
Thank you.